Hello and welcome to the live session of Narayana IAS Academy. I'm Yogesh Kotavar and I'll be taking up a burning issue of this time that is related to the small satellite launch vehicles. Recently, ISRO has launched successfully the developmental flight of small satellite launch vehicle, that is SSLV. So we'll study what is SSLV, what kind of launch vehicles India already has, and from the syllabus perspective it can be asked in prelims as well as mains, because in mains GS paper 3 mentions about awareness in the fields of space. So the article is very important. You can look at this previous year question. It says India has achieved remarkable successes in unmanned space missions including Chandrayaan and Mars orbiter mission, but has not ventured into manned space mission. What are the main obstacles to launching a manned space mission, both in terms of technology and logistics? Examine critically. And to answer such questions, you should have a good idea about all the launch vehicles, all the space missions of ISRO. Now moving ahead, what is the context? We said that recently ISRO has successfully launched the third developmental flight of SSLV. First of all, what is developmental flight? There are two types of flights. One is developmental, other one is operational flight. See, if scientists or engineers are developing a launch vehicle, while developing, if they are testing it, they are sending it into space, such flight will be named as developmental flight because it is still in the developmental stage. But once it is developed completely, then if you are sending it into space, it is called operationalization and it is called the operational flight. So here we are saying SSLV is now in the developmental stage because it was the third developmental flight. This flight took place from the Satish Dhawan Space Center in Sriharikota, which is in Andhra Pradesh. Now first of all, what is launch vehicle? You can say launch vehicle is nothing but a normal vehicle just like our bus, our car or our bike. So these we use to move from one place to another. Similarly, a launch vehicle is a vehicle which we use for sending something from the earth's surface to the space. That something could be your satellite, spacecraft or any scientific instrument. Now when you are sending this thing, there is a problem because when you move away from the earth's surface, there is a role of gravity. Gravity will not let you go. So to send something, you need a very powerful thrust. A powerful thrust which you will apply towards that gravity, and this is how this particular launch vehicle will move ahead. Now what happens is that this launch vehicle has a very powerful propulsion system. So you can say propulsion system is nothing but made up of your engine and fuel. So just like your bus, car, bike, they too have engine and fuel. So in bike you have IC engine, then you have some fuel, for example the petrol. Similarly, the launch vehicles will have a propulsion system in which there are multiple engines and multiple fuels, and these will be used to send the satellite into the space. Okay. Now moving ahead, these launch vehicles look like this. We call it rocket, sometimes people call it rocket or carrier rocket, and the satellite will be put over here, and all the entire thing will be constructed in different stages. So this will be called stage 1, this will be called stage 2, this will be called stage 3, and each stage will have its own engine, will have its own fuel. Second one will have its own engine, its own fuel. Similarly for the third. Now what happens is that once the flight takes place, this fuel in this first stage will burn. The engine will work in the first stage and the launch vehicle will start moving ahead. Once this fuel is exhausted, once it is completely burnt, this part of the launch vehicle falls back on the surface of the earth and only the remaining part will move ahead with its journey. After some time, the fuel of this second stage will be completely exhausted and then this second stage will fall back on the earth. Similarly, the third one after some time. So through this process, we say that the launch vehicle ensures that a satellite goes from the surface to the particular orbit in the space. Okay. Now moving ahead, if you look at the launch vehicles India has, the first launch vehicle India had was satellite launch vehicle, that is in short SLV. This India used for the first time in the year 1980 by sending the Rohini satellites in the space. Now, every launch vehicle has a payload capacity. Now, what is payload capacity? That means the weight the particular system can carry. So, for example, there is a payload capacity of 200 kg, for example. That means this launch vehicle can send at max 200 kg of a satellite, not more than that. So, in case of SSLV, we saw that the capacity was very less. So, after some time, ISRO developed a new thing called ASLV, that is Augmented Satellite Launch Vehicle, and this had payload capacity more than the SLV. Then after some time, ISRO worked on these launch vehicles and came up with a new one named as PSLV. This is named as Polar Satellite Launch Vehicle, and this is very important. This launch vehicle is considered as the most reliable launch vehicle of ISRO till now. Because if you see, it has taken up total 57 flights successfully and only 3 failures. That means it is very reliable. It is also named as ISRO's workhorse. Now, if I talk about its payload capacity. So, payload capacity is calculated in two terms. One, how much it can send the weight in the low Earth orbit and how much it can send in the geosynchronous transfer orbit. Now, low Earth orbit could be understood as this is the Earth's surface. So, this is the low Earth orbit, and if you go far beyond that where you send communication satellites, it is called geosynchronous or geostationary Earth orbit. And to send here, whichever orbit you choose is named as GTO. Now, in case of PSLV, its payload capacity is somewhere around 1000 to 1750 for the low Earth orbit and 1425 for this GTO, which is very good. And we have used this PSLV for many missions. We used it for Chandrayaan 1, we used it for the Mangalyaan mission also. Okay, so important one. Now, after some time, ISRO again developed a new launch vehicle named as GSLV, that is Geosynchronous Satellite Launch Vehicle. Now, this is having higher capability to send payloads in the space. So, for example, you see in the low Earth orbit, it can send somewhere around 5000 kgs of payloads, and in the GTO, it can send somewhere around 2500 kg of payload. So, GSLV is having higher capabilities than the PSLV. And in this GSLV, ISRO made a new modification and brought in GSLV Mk3. This is the heaviest rocket system India has right now. It is also known as Bahubali rocket of ISRO. Its capacity, you can see, it can send 8000 kgs of payload to the low Earth orbit and 4000 kgs of payload in the geosynchronous transfer orbit. So, this one is the heaviest one India already has. Now, moving ahead, what is small satellite launch vehicle? The name itself suggests it's a small one. So, here we are planning to launch small satellites. How it comes into picture, see. Earlier we used to send PSLV or GSLV, and we said that here we used to put satellite. But ISRO did not send one satellite at a time. Rather, ISRO used to put multiple satellites in the same system and send it in one go. So, maybe in one go there are 50 satellites being sent. So, if you go to ISRO and say, sir, I have a satellite, can you send it right now? ISRO used to say, no, we can't send it. We need to wait till this gets completely filled. Now, ISRO is saying that if someone comes to us to send even one small satellite, we will have the ability to send that through this small satellite launch vehicle. It is going to be very smaller and it can send maximum up to 500 kgs of payloads. So, it's made for the miniaturized satellites, we can say. Now, look at the key features. First of all, it is a 3-stage solid propulsion system. That means the rocket will have 3 stages, 1, 2, 3, and in all of these, solid fuel is being used. See, fuel could be liquid just like petrol or kerosene. Fuel could also be in the solid form. And solid fuel is considered as better than the liquid fuel when it comes to handling. It is very easy to handle. And if you burn the solid fuel, once you burn it, it will completely burn. It's not the case like the liquid fuels, which you can even stop. While burning, you can stop the phenomena. In case of solid, you cannot stop it. It is considered to be better in that case. Next thing which this SSLV has is the VTM module, velocity trimming module. Now you can compare this with the bike parking system. When you park your bike somewhere, what you try to do is that you try to control the speed of the bike in such a way that you park in a very precise manner. You want to control its trajectory also. So similarly, we will do the same phenomena in case of SSLV, wherein this VTM module will allow you to precisely put the satellite in its location. So you can put it precisely in any location or any orbit. Then the turnaround time will be reduced very much. Here you can say that earlier when ISRO used to build any project, build any launch vehicle, they used to take somewhere around 70 days, and at least 60 people were required in terms, just like scientists or any engineers, at least 60 people were required. But now if you are building an SSLV, you hardly require time of 72 hours and you hardly require 6 people to build this entire project. So very good. Then you don't require much infrastructure just like PSLV or GSLV. So here operational cost will be reduced, and the cost reduction will allow you to be a good market player. So many players from national or international floor, many customers will reach out to you and say that, sir, please send our satellites. Now here we can say the significance of SSLV lies in its commercialization. So as ISRO can think about expanding its market access, expanding its market and commercialize the space sector completely. There is also a strategic angle to it. See, if a country is not able to send its satellites earlier, in that case it will become dependent on other countries, and that is not a good thing. For example, if you want to send a satellite which is very important from defense perspective and other countries are not allowing you to send that, then you become very much dependent and you become very weak. Here, when you have the ability to send through SSLVs, it gives you strategic autonomy in the space operations. You can send satellites related to defense, communication or scientific purpose related anything. Now moving ahead, there is increased access to the space. When you are saying that we can even send small satellites, here we can have an organization or even a college where students are making a satellite, a very small satellite, and they may go to ISRO and say we want to send this to the space, and they will be able to do this. Earlier space sector was restricted by the access, only the rich class or the elite class could reach out to this space sector, but now you are trying to democratize the space sector, and when you democratize this, it will lead to more innovation, more research and more development in the space technologies. And this on-demand service, it is going to be really good, wherein we can say the market will grow in upward direction. So thank you so much for watching this video. If you want any such updates further, please like, share and subscribe to the YouTube channel of Narayana IAS Academy. Thank you.